Hi students, let us welcome back to the sets. Okay, so in the next example, previous video which is taken that what is meant by set and what are the different forms of the set and some example converting set builder form to roster form into set. What is the set? A set is a collection of well-defined object is said to be a set. There are two types of the representation. One is a roster form of the set, another one is a tabular or a set builder form. Roster form, all the elements of the set are written or separated by the comma and enclosed in a flower bracket. Order is immaterial and repeated elements are going to write only once in the roster form. Set builder form means the characteristic or property of the elements is going to mention, and the conversion is just know that roster form to set builder form into roster form. Now here I am just converting. This is a set builder form is the converting into roster form. Write the following set into roster form. Similarly, just later previously is a several problem. In that continuous problem, sixth problem, 5 problems is over. Okay. F is equal to x such that x is a prime number which is a divisor of 60. X is a prime number which is a divisor of 60. Already know that prime number. What are the prime number? 1 is not a prime number. 2, 3, 5, 7, 9 is not a prime number. 11, 13 and 15 is not a prime number. 17, 19 and so on. These are all the prime numbers are there. Out of these prime numbers, we have a x. X is a prime number. How we need to choose the prime number? That prime number is divisor of 60. That prime number is divides the 60. So factors of 60. In that factors of 60, which is the prime number is that is our required value. Is 2 is a divisor of 60. 2 divides the 60. Yes, obviously it is 2 divides the 60. Next, I am just going to consider only the prime number. In this prime number set, I need to choose a divisor of 60. Okay, 2 is correct. Next, 5, 3. 3 is a prime number. Yes, 3 is a prime number, divisor of 60. Next, 5. Yes, 5 is a prime number which is divisor of 60. Next, prime number is 11. 11 is not divides the 60. Next, 13, 17 and remaining values are not a divisor of 60. Obviously prime numbers are there, but divisor are not a divisor of 60. The required roster of the set is 2, 3, 5. This is the required set of divisor of 60 and as well as prime number. So this is a particular, this type of examples are very important for the 1 marks session. Now let's take the third type of the problem. Just for what are the following? For the following, which one is the set and which one is the not a set? We just recognize it. First one is, take an example. Which one of the following are set? Which one of the following are set? Which one of the following are set? Which one of the following are sets? In that, first one is the collection of all the months of year beginning with the letter J. Okay, here we need to write that as property is given. On seeing this property, whether it is a set or not, whether it is a well-defined objects or not, we need to recognize which of one of the following are set. In that, the collection of all. Collection is that what is the collection is? They are meaning all the months of the year. In a month, how many years are there? There are totally 12 months are there. Out of the 12 months, yes, it is a well-defined object. Okay, no problem. So out of the 12 months, they are again distinct the condition. What is the distinction of the condition? Beginning with the letter J. Out of the 12 months, beginning letter is a J, then what is the required objects belong to the particular set? A, that I just denote this set as a A. Okay. So January is that, okay. January starting beginning letter as a J. Okay. February starting letter as a Y. But here it is not possible to include leave it. Next, March is not possible, April is not possible, May is not possible. Next, June is there, October, June, July, August is not possible, September is not possible, October is not possible. Then October, November, and December. But out of the 12, only the 3 months have starting letter as a J. This is the required one. And whether now we need to say that whether it is a set or not a set. Yes, obviously it is a set. Yes, it is a set. Is that clear? Okay. Next, here only thing, given thing or given property whether it defines a set or not a set. Only thing we need to mention it. Yes, it is a set. This part is not necessary. Just for your understanding purpose, I just written. Next, second one is the collection of 10 most talented writers of India. 10 most talented writers of India. The collection of 10 most talented writers of India. Okay. Whether it is a set or not a set. Collection is that collection of what? Writers is that particularly talented writers. How many writers we have to mention? 10 most talented writers. Whether it is a well-defined object. Suppose if they are mentioned to that collection of 10 writers of India, we can mention what are the writers are there. Several names are there. Whoever is there. Dara Bendre, like that, Chetan Bhagat, like that, Mansi Chand, like that. The several writers are there. APJ Abdul Kalam is there, like that. Several writers are there. Out of that writers, collection of 10 writers we have, right? We can collect 10 writers, but talented writers is there. Talented writers means it is not a well-defined object. Why it is not a well-defined object? Means according to my view, suppose the writer X is a talented. Suppose another person is there. For example, you people is there. You. According to you, some other person Y might be a talented. Another person, some Z person might be a talented. Why here? What is the wrong thing happened is talented. The word is disturbing for us. What is that? For the well-defined object, this thing is problem. What is that? Talented. If they have not mentioned a talented, 10 most writers of India, we can mention it, no problem. But talented is that how to measure the talent of the writers? Depending upon but it is depends on here their writing or books, whatever. But talented is that talented means person to person it differs. Person to person it might be differs their talents of the writers. So that reason, due to the talented writers, it is not a set. It is not a set because of talent. It is not a well-defined object. Person to person it is differs a talented writer. So that reason it is not a set. Come to the previous example. Wherever you just go on the earth, whatever you just tell that the all collection of all the months of a year, beginning letter is a J. Everyone used to say these 3 months only. Apart from these 3 months, any other months are there, which is not possible to say. But here, in this case, it is possible. In this case, it is possible. Suppose if I have written X, Y, Z are the most talented writers according to my view. Other person used to say that A, B, C are the most talented writers. I am not mentioning any particular names of the writer. I am just taking in general. According to my view, XYZ are the most talented writers, but other persons, according to you, I is supposed to say that A, B, C are the talented person. Like that, person to person, it is different, so that it is not a particular set. It is not a set. It just mentioned that it is not a set. That's all. Next, the collection of all even integers. Collection of all even integers. Collection of all even integers are there. Okay, collection of all even integers. Whether it is a set or not a set. Even integers are there. Already you know that integers. For example, -3, -2, -1, 0, 1, 2, 3, so on up to infinity. This is the integer set. Is that integer set is always denoted by capital letter Z. Okay, integer set. In this integer set, we need to select that all the even integers. What are the even integers? 0, consider as a even. 2, 4, 6, 8, so on. This is said to be a even integer set. Yes. Okay. This is a particular example. This is in the set builder form. Is that I just written a roster form. Now it is a set or not? Set. Yes. Obviously it is a set. Next, fourth one is a collection of a novel. Collection of novels written by the writer. Collection of all the novels written by the writer A, B, J. Collection of all the novels written by the writer A, B, J. Whether it is a set or not a set. Yes, obviously it is a set. Particular writer is the APJ Abdul Kalam. Is the writer? Yes, obviously. How many novels he has written? Whether he has written a zero number of novels, 1 novel, 2 novel, 3 novel. Obviously, look at the number of novels. Obviously, look at the collection of novels written by the particular writer. Is that? Yes, it is obviously a set. This type of question may arise in a 1 marks session. Okay, next point is types of the set. What are the different type of sets are there? In that, first one is empty or void or null set. What is meant by empty set or void set or null set? Different names are there. Empty set or a void set or a null set. None of the set. Just for a names are different. Anyway, what is meant by empty set? Here, for discussing the types of the set, a word itself telling that empty set. A set is nothing but collection of well-defined objects. Empty set is a set which do not contain any elements in it. What is the empty set? Empty set, a set which do not contain any elements in it. A set which do not contain any elements in it is said to be an empty set or is said to be a void set or said by null set. The always empty sets are denoted by the Greek letter pi. Empty sets are always denoted by Greek letter pi. Read as a pi is equal. Now particularly denoted by pi. Particularly take an example. What are the example means? Suppose I just take the example set A is equal to writing in terms of the set builder X such that X is equal to, or else I just say that X such that X is a even prime number. X is a even prime number and it is more than, and X is a even prime number and x is greater than 5. X is a even prime number and x is greater than 5. Whether it is a set or not a set. Obviously, property is going to satisfy. How many elements are present or not present, we can discuss it. Yes, obviously, property is that we can say that it is a set. Now, check it. How many elements are present in x? We need to choose the x value. How the x value is that? X is an even prime number. First of all, what are the prime number? 2, 3, 5, 7, 11, 13, so on. These are all this is the prime number set. Out of this prime number, even prime is there. What is the even prime number? There is only one prime number is there, which is even prime number, that is the 2. Except the 2, remaining are all odd numbers are there. Now, I need to choose the even prime number. That number should be greater than 5. Is there any such number, even prime number greater than 5? There is no elements in it. So that it is a set. Sometimes they used to add that 5, or sometimes they used to say that empty, just a flower bracket. So this is the empty set denoted by the letter 5. Another example I just used to take that. Second set b is equal to x such that x is a real number and x square is equal to minus 1. X is a real number and x square is equal to minus 1. We need to write the set contains the element x. How the x is there? X is the real number and x square is equal to minus 1. Already know the real number set. What is the real number set? Real number set is nothing but negative infinity to positive infinity. Whatever the numbers are there, all the real numbers are there. And apart from that, integer. I just mentioning the set to be. This is said to be a real number set. These are the Rx denoted as real numbers. Z is nothing but integers. What are the integers? 1, 2, 3, so on. Negative side 0, minus 1, minus 2, minus 3, minus 4, so on. Negative. These are said to be a integers. And if they return Z plus, is nothing but positive integers. If they return a Z minus, that is nothing but the negative integers. And W is denotes for whole numbers. And n is denotes for the natural numbers. There are different sets are there. Okay. So out of that, now they are telling that real numbers, all these integers, positive integer, negative integers, and as well as natural numbers are present in the real numbers. And already people have studied the complex numbers. What is a complex number? A number which is of the form a plus ib or x plus i1, where a and b or x and y are the any real number. I is equal to square root of the minus 1. Already people have know that. Anyway, here x is a real number and x square is equal to minus 1. If I solve the x square is equal to minus 1, what happens? X is equal to plus or minus square root of minus 1. Square root of minus 1 is a real number or complex number? It is a complex number because it is a value of I. So that it is does not contain any real number which is satisfying both the value. So that it is a null set. Similarly, third example I just take C is equal to x such that how the x value is like means x is a natural number. X is a natural number and which is lies in between 1 to 2. X is a natural number which is lies in between 1 to 2. 1 and 2 are the natural number or positive integer. In between 1 and 2, is there any other natural number? There is no other natural number in between the 1 and 2. So that there is no elements belong to this set. So this is also a null set. So this is the empty set or a null set or a void set. Once again, what is an empty set? A set which do not contains any elements in it. There is no elements present in this set. Here also there is no element present. Here also there is no elements are present. Obviously properties are, but satisfying this property there is no elements are present. Here also property is that particularly obviously it is a set, correct? But satisfying this condition, there is no elements are present in this set. Therefore, these are said to be a null set. A set which do not contains any elements in itself is said to be a empty set. Is denoted by pi or just a empty parenthesis or a lower bracket. This is said to be a empty set. Suppose I just take a particularly node. What is a node is being got here particularly. Suppose if a set consists of only one element. Suppose a set consists of at least one element. A set contains at least one element. At least one element in it is called non-empty set. Is called a non-empty set. Empty set and the non-empty set. Empty set is nothing but there is no elements contained in it. Non-empty set is nothing but at least one element should be present in the set. That is said to be a non-empty set. For example, I just say that suppose the set A is equal to x such that x is a natural number and x is lies in between 1 to 3. How many elements are present? It is a set builder form or Rocher form. It is a set builder form. Write it to the Rocher form. What is the Rocher form of this set? X is a natural number and lies in between 1 to 3. There is nothing but 2. 2 is the only one element. This set is said to be a non-empty. Non-empty means at least one element should be present. So this type of set is said to be a non-empty set. Next, apart from that, singleton set. Singleton set. What is a singleton set? Word is telling that single. A set which consists only one element in it. A set which consists only one element in it is said to be a singleton set. What is a singleton set? A set which consists only one element in it is said to be a singleton set. The same example I just take singleton set. Example is this one. Suppose non-empty set, I just replace this one. Suppose if I write 5, x is lies in between 1 to 5. That means 1 is not present. 2, 3, 4. This is said to be a non-empty set. At least minimum. Kadima the one element irvek set. Adake ನಾವು non-empty set ಅಂತೀವಿ. Singleton set ಅಂದ್ರೆ set one element irvek. Particularly only consists of only one element. That means x such that x is a natural number and x lies in between 1 to 3. This is the singleton set. If you need a Rocher form, you can write 2 element. This is said to be a singleton set, non-empty set, and the empty. Empty set means a set which do not contains any element in it, denoted by or a open lower bracket. Non-empty set means at least one element is present in the set. Singleton set is nothing but it should be contain only one element in it. Next one is the third one, finite and infinite set. Finite and infinite set. First of all, finite set. A non-empty set or a empty set. A empty set and it contains and countable. A empty set and it contains empty set and a set contains and a set contains countable number of elements. Countable number of elements in it. Countable number of elements in it. A empty set and a set which contains countable number of elements in it. is said to be a finite set. Otherwise, it is said to be a infinite set. What is a finite set? A empty set. Empty set is also considered as a finite set because empty set means how many elements are there? Zero number of elements are there. In a empty set, this is an empty set, but this is not an empty set because it contains a element zero. It is a singleton set. This is the empty set. Very important one. Remember, this is empty set. This is the singleton set. This is the singleton set. It is not a empty set because it contains a one element. What is that element? Zero is a element. It is a singleton set or a not empty set, and it is a empty set. Okay. A empty set means countable number of elements. How many numbers are there? Zero number of elements are present. It is also a finite set. And a set contains countable number of elements. Whether a set contains a 10 number of elements, 20 number of elements, 1000 number of elements are present, or 1 lakh number of presents are there. How many number of elements are present? We can easily need to count it. If it is possible to count the number of elements, then it is said to be a finite set, and otherwise it is not possible to count the number of elements in it. It is said to be a infinite set. How to find the, or first of all, here I just take the example for the finite and the infinite set. What is the example for the finite set? E is nothing, but there are several examples we can give. What is the particularly? Particularly set A as this slide. Set A is equal to x such that x is a odd numbers or odd integers less than 100. Can you people count the number of elements which are present in this set? Yes, odd integer. How many odd integers are there? There are so many odd integers are there. Particularly less than 100. Less than 100 odd integers we can easily count. This is said to be a finite set. Suppose another set x such that x is a factor of or factors of 1000. X is a factors of 1000. 1000 number is that. For this number, whatever the factors are there, you can easily write yes, it is a finite set. Similarly, set C is equal. Now I just take another example. X is equal to x such that points on the line, or points on the circle, on the circle, how many points are present? On the circle, how many points are present? On the circle, already know that set of all the points in a plane which are equidistant from the fixed point. This is the circle. On the circle, how many points are there? There are infinite number of points are there. These two are a finite set. This is the finite set. This is the finite set, but it is an infinite set. Here in this set, there are uncountable number of points are present. Therefore, it is said to be a infinite set. Like x such that x is a even integer. X is a even integer. How many even integers are there? Total in integer set. How many even integers are there? There are infinite number of integer sets are there. Therefore, it is a infinite set. Are you following? This is the infinite set. Very simple concept is the infinite set. And apart from that, here a set of all the human beings. Set of all the human beings on earth. Set of all the human beings on the earth. Is it a finite set or infinite set? Yes, obviously it is a finite set. Some people might get the confusion of this one, right? How it is a finite set? Set of all the human beings on the human beings. We are the human beings, persons. Is that clear? Is it possible to count the number of people present on the earth? Yes, obviously on the earth, number of people we can count it. How? Census every 11 years. we are going to, India is going to do, or whole world is going to do the census on that region. On that basis, we can easily get the number of human beings are present on the earth. Approximately we can get it, no problem. So daily few members are getting birth and few members are going die, no matter at all. But particular we can get particular time. After particular time, we can easily get the number of human beings on the earth. Obviously, it is a finite set. It is not possible to write it as a infinite set. It is a finite set. Is that clear? Right. Here, I am just literally telling that number of elements on the set, number of elements in the set, it is a finite number. How to find the number of elements? That is said to be a cardinality of the set. Cardinality of the set. What is the cardinality of the set? Is nothing but suppose the set A is the cardinality of the set is denoted by n of A. That is nothing but number of elements. Number of elements in the set A. Number of set elements in a set A. For example, previous classes later. For example, suppose A is equal to 2, 4, 6, 8, 10. Suppose it is one set is there. How many elements are present in this set? 1, 2, 3, 4, 5. Therefore, n of A, number of elements present in the set A is 5. This is how we can easily count the number of elements in the particular set. That is said to be a cardinality of the set. What is the cardinality of the set? Cardinality of the set is nothing but number of elements present in the given particular set, and it is denoted by n of A. N of A is represents the cardinality of the set or number of elements in a set A. Is that clear? So these are the particularly finite and the infinite set, and particular example for finite set as well as the infinite set. Okay, next thing, equal sets and equivalent set. Equal sets and equivalent sets. Previously it is taken finite and the infinite. And particularly another few more examples for the infinite set is set of natural number, set of real numbers, set of integers, set of positive integers, set of negative integers, or set of rational number. What are the rational number? A number which is of the form a by b, provided that b is not equal to 0, like that. There are several types of that. Set of complex numbers, like that. These are all the infinite sets. Okay. Apart from that, and cardinality of the set, number of elements which are present in the set, that is said to be a cardinality of the set. Next one is equal set. Little bit similarity is there, less difference. Okay, equal set. What is the equal set? Is two non-empty set. Non-empty set is nothing but which contains at least one element in it. Two non-empty sets A and B. Two non-empty sets A and B are said to be equal. Are said to be equal. These two sets A and B are said to be equal when it is if all the elements of the set, or if both sets have the same elements. Both sets have the same elements in it. Both sets have the same element in it. Is said to be the equal set. Suppose the set A is that and set B is that. We are required to say that these two sets are equal. When we can say that these two sets are equal, whatever the elements are present in the set A, the same elements will be present in the set B. Then we can say that these two sets are equal set. For example, what is the example? Means same element should be present. Okay. Now I just write the set A is equal. Letters of the word. Letters of the word. Letters of the word pool. Letters of the word pool. And set B is letters of the word. Letters of the word letters of the word follow. I just consider two sets. One set is letters of the word pull and second set is letters of the word follow. So these are the set builder combination. Write in a row form. What is the row form of the set A? Letters of the word pull. What are the letters are there? W is there, O is there, N is there, M is there. Okay. Write the row form of the set B. What is the row form of the set B? Letters of the word call. Okay. M is there, O is there, N is there. Again N is there. Lifted elements are going to write only once. N is there, O already is written, and W is there. Now see the equal sets. What is the equal set definition? Two sets A and B are non-equal. Yes, at least one element is present. Are said to be equal. If both the sets have the same elements, whatever the elements are present in the set A, the same elements must be present in the set B also. W is there, W is there. Okay. O is there, N is there, M is there. Same elements are there, and already know that in a representation of the sets, order is immaterial. Whatever the order, we can write it. So these two sets are said to be a equal set. So this is the particular example for the equal set. What is the equal set? Equal set, two non-empty sets A and B are said to be equal if both the sets have the same elements in it. It is said to be a equal set. Next thing is equivalent set. What is the equivalent set? Is nothing but equivalent set. Equivalent set is nothing but again the same thing. Two non-empty sets. Two non-empty sets are said to be two non-empty sets. A and B are said to be equivalent. Are said to be equivalent if N of A is equal to N of B. N of A is equal to N of B. What is the N of A? What is the N of B? N of B is nothing but cardinality of the set A and cardinality of the set B. Number of elements which are present in the set A and number of elements which are present in the set B. Both are equal, then those two sets are said to be equivalent set. For example, set A is equal to 2, 4, 6, 8, 10 is there. And set B is equal to A, E, I, O, U. These two sets are said to be equivalent set. These two sets are said to be equivalent set because what is the cardinality of the set A? Number of elements which are present in the set A is 5. What is the cardinality of the set B? Number of elements which are present in the set B? 5 is there. So both are equal. N of A is equal to N of B. Therefore, these two sets are said to be equivalent set. Are you clear? Equivalent set, equal set. What is the difference between the equivalent and equal set? Equal set means both of the set have the same elements in it. Same elements, obviously, same elements means obviously same number of elements will get nothing to worry. Equivalent set, equal set is nothing but same elements in it. Equivalent set is nothing but cardinality of the two set is equal. Cardinality of the two set is equal. Whatever the number, whatever the different element might be present, it is not necessary that same element. So cardinality of the set is equal. Then those two sets are said to be equivalent. Equal means both the set have the same elements in it. Okay, equal and the equal. Now here, particularly we can take a note. What is the note we can take? Is nothing but can we say that equal sets are always equivalent? What is the note? Equal sets are always equivalent, but reverse is not possible. Reverse means converse is not possible. Equivalent sets are need not be equal. Equal sets are always equivalent. Equal set means same number of elements and same elements are there. So therefore, N of A is equal to N of B, A is equal to B set. Nothing to worry. Equal sets are equivalent set. Every equal sets are equivalent set. But the converse is need not be true. Need not be is nothing but sometimes it will be true and sometimes it will not be true. So particularly we mention what is the note? Equal sets are always equivalent sets. Equal sets are always equivalent set, but the equivalent sets need not be a equal set. Equivalent set need not be a equal sets. Okay, so with this types of the sets, I just stop here. The remaining 2-3 types are there. We'll discuss in the next video. So till that, this is practice. See the definition, go through the NCERT book and just clearly read the book. And apart from that, according to on seeing the video only, just mention the note. Whatever the main point you just need and examples, particularly definition and particularly example. On seeing the example, you must get clarified about the definitions. Okay, we'll continue in the next video. Okay, thank you.